Hello guys. Um, Everyone these days is making YouTube videos, so I thought maybe I'll just also make one and see how the response goes. Everyone, I first of all let me introduce myself. My name is Divakar, and I've always loved physics because it always explains the things around us, and I just wanted to explain things in the way that I have understood. So I'll just start off today with my first video, and that will be on one of the most basic things that anyone learns, and that is Newton's laws. So I just wanted to just explain the Newton's one law, and that was Newton's second law, and perhaps which is one of the most important laws that we're going to encounter in our lives, and perhaps which most of the engineers will be using to derive most of the things. And in 11th and 12th in India, at least, half of the syllabus is based on just this one law. If you understood this correctly, you can understand many of the things that nature tries to offer us. You can understand fluid mechanics with it, you can understand a lot of phenomena. But the only thing is, you need to understand what it correctly means. What does Newton's second law say? Is we all know what it says. Mathematically, it says F is equal to m into a. What this F actually is, oh my god, I'm out of the frame, I guess. Once, just let me see. This F is equal to m times a. What is this? This F, this m, and this a. We need to understand this correctly. Okay. You take any body. Most of the people take square shaped, so I'm also taking a square shaped body. It has a mass m. Okay. And let this be anywhere in the universe, and this body, this thing, this can be anything. Okay. But usually take it to be of a size that we encounter in our day-to-day lives. That is, let it be a book, or let it be your mobile phone, or let it be any stone that you see while going to your class or something like that. So basically any body, okay, and let it be rigid. Okay, just for explanation purposes I'm telling you, let it be rigid and let it be kept anywhere in the universe. Okay, what this F says is F is the force, this is the force that I apply on this body. Okay, so F is the force that I apply on the body, that will be equal to the mass of this body times the acceleration produced in the body. And that's all what it is. All you need to know is that the force that you apply is responsible for the acceleration produced in the body. Or you can understand, if there is a body that you see is accelerated. Now we all should know what is acceleration. Acceleration is the rate of change of velocity, right? That means if a body is moving with a constant speed, let's say the body is moving with a constant speed v. Okay, if this is constant, oh my god, I'm out of frame. Okay, let me move this a little bit here. Okay, if I have a body that is moving with a constant speed v, this is a constant, then we don't say it is accelerated. It's not accelerated. If this v changes with time, then we say it is accelerated. Okay, so Newton's law states that in order for the velocity of a body to change, we need a force to do that. And that's all it says. Once you get a hold of what this means, and a lot of things can be explained. Okay, for example, let me now rub this. So we know this F is equal to, sorry, I'm again out of it. F is equal to ma. Okay. This F, by the way, is not just the force, it is the resultant force. Obviously, this is the mass and this is the acceleration produced in the body. So we can understand this in a lot of ways. If I have, let's say, a body, this is the surface of the earth. I'm taking this body in my hand. I have my hand here. Okay, these are my fingers. Okay, I'm taking it up with a constant velocity v. Okay, is this body moving with constant velocity? Yes. And what does our Newton's law tell us? That if there is no acceleration, if it is moving with constant velocity, that implies that it has no acceleration. Correct? And if it has no acceleration, then there is no force on this. Yes, but we all know there is a force of gravity on this. If I draw the gravitational force, how much will be this? If the mass of this is, let's say, m, gravitational force is mg. This is the force. I'm representing it with a vector on this body that I'm moving up with velocity v. But there is a force on this body, but there is no acceleration we are seeing. So what is happening? Obviously, this F, as I told you, is the resultant force. So if I have mg downwards, there must be a normal reaction that my hand is giving on it in the upward direction, and these two have to be equal since it is not accelerated. So that means what? That means the normal reaction from my hand should be equal to the weight. This thing comes out as a result of this equation, by the way. Okay, since we know that there is no acceleration, thus we can say that the total force on this should be 0, and the only two forces acting on it are the gravitational pull and my normal reaction. Okay, and that's why n is equal to mg. If, let us say, this was not moving with constant velocity, I'll just rub it now. If this body, and this is my hand, okay, these are the fingers of my hand, I'm moving it up with, let's say, 1 meter per second square acceleration. Okay, I know there is acceleration now. That means what? There should be a resultant force on it. In which direction? Obviously in the direction of the acceleration. What are the two forces acting on it? The gravitational pull and the normal reaction. The resultant of these two, that is, obviously this is acting downwards, the normal reaction is upwards.